Hello, I'm Uezono from AGB, Asahi Building Wall Company in Japan. We are facade specialists in Japan, dealing with wide range of materials. One of our strong areas is GRC. Today, I'll talk about GRC design trend in Japan and their technical underpinnings. GRC was introduced 50 years ago by Pilkington brothers to Japan. GRC was first adopted in 1976, but didn't catch on because of Japan's climate conditions. Japan is an archipelago. Summer are hot and humid, and there are typhoons. Winter are cold and dry, and there are also regions with heavy snowfall. We have had to develop our own GRC mixture and adapt techniques for Japan's environment. Japan is very earthquake-prone. 1,976 earthquakes were observed in 2022 alone. There have been also major earthquakes causing widespread destruction to life and property. The epicenter of the 2011 earthquake was under sea, causing large tsunami waves to ripple over much of East Japan, leading severe damage to regions close to the epicenter. In urban centers, tremors were detected. The oscillation frequency of the earthquake resonated with the natural period of the structures, sparking worries about the structural integrity of buildings in subsequent earthquakes. As a solution, GRC was used as it was lighter than precast concrete. Because of this, GRC is often used in tall structures in cities and symbolic buildings. I'll proceed to introduce some of our projects with a focus on how the engineering caters to Japan's environment constraints and sustainability demand. The Azabudai Hills Modern Urban Village was conceptualized as an environment that was compact and cozy like a village, while also having the sophistication of an international metropolis as well. The street-level design is by Heatherwick Studio. A three-dimensional net frame GRC structure is adapted to seamlessly blend the water features and greenery. Work began in 2021, and we are now in the final phase of the project. We would like to share some of the thought and engineering processes toward satisfying the environmental and design requirements. Here are some of the aspects we worked on. Earthquake prevention solutions in the facade panel allocation. Climate-proof finishes, implementing 3D forms with digital tools, and enhancing durability to meet sustainability demand. Firstly, in regard to the earthquake, we usually use the sway and lock method to deal with story displacement. For the other project, we avoided allocating panels that would describe different structures and affixed all of them on the same structure. This is so we don't have to consider story displacement. The damper for the steel structure was projected to move as much as 60 mm in earthquake. The placement was such that we absorbed the 60 mm with the seams in between the GRC panels. The steel structure was finished on 4th side GRC, and the right picture shows this. At the bottom of the pier panel is not accessible. We adapted a method of installation that didn't need fasteners. The panels were affixed only at the top, and heat expansion and construction would be absorbed along the length of the panel. In regard to the climate conditions, nearly all buildings in Japan have to have some kind of extra finish. The same applies here. Due to the special finish, we conducted specialized tests for this purpose. We performed neutralization, infrared, heat-cool cycle, and other accelerated testing on 10 types of coating, and assessed the deterioration of the exterior, the waterproofing, the surface strength, the tightness, and anterior durability. We choose the best materials based on the testing result. The complexity and number of materials defined our coating testing for this project. But typically, we do routinely conduct simpler testing for finishes. In regard to the shape was free-form, utilizing the flexible properties of GRC to the maximum extent. This is an only except. Besides this, we have cross shapes, T-shapes, M-shaped structure and deal with. We automated as much of the work processes as possible due to the complexity and number of different shapes. Such free-form structure are increasingly common even outside major cities, accelerating the automation and digital transformation of GRC design and production. This is a unique finish using natural aggregate stones. The design envisioned a massive net spring up from beneath the ground. We used various stones to achieve that effect. In order to realize this finish, we made many samples indeed. This is an example, but we made samples with a high proportion of aggregate, a low proportion of aggregate, and white cement, and Portland cement, and other many combinations. We extensively deliberated on this from the design early stage. The GRC was composed of 2 layers, the aggregate layers and GRC layers, to fulfill both structural and design elements. In the final result, we managed to fulfill strengths and design requirements while creating a durable product. This is one of the tools we used to automate our processes. As the manufacturing plant is in China, and the finish and installation is in Japan. The management process was dauntingly complicated. We used RFIDs to identify and manage the flow of products. In doing so, we reduced the amount of man-hours, unified data, and reduced human input errors. The 3D model on the right shows how we visualize our compression rate. Each color represents each product. The project is ongoing, and as such, we still don't have the full view of the structure. The facility is expected to open in autumn of 2023. Kindly do The next building is National Federation of Credit Cooperatives. The grid-like traditional facade is used as this is supposed to be a grand building. In line with classic styles, we use the GRC for the grid pillars. The total area is about 35 square meters and fixed with inlaid ceramic tiles. Here, I would like to introduce the aspect we verified through testing. Here, we decided to eliminate consideration about the structure wrapping by fastening all the panels to the same structure. As this decision was made very early in the building design process, the slab design was amended to accommodate the facade. In order to make the internal space look bigger, we worked on the fine details, reducing the seams and borders repeatedly. Clients emphasized that the components had to be as thin as possible. Next, I would like to talk about the finish. We use ceramic tiles here. Tiles are normally not used in high-rises for fear of earthquake and climate conditions. However, there has been enduring demand for the unique texture and durability of tiles. Also, Japan has made ceramic tiles indigenously since 600 AD. We have applied these traditional materials and grid structures to modern buildings. In order to do so, we conducted multiple strength and destruction tests to scale to verify its safety. In this test, we determined that the material was able to bear load 2 times as much as the conditions we were given. We managed to realize the use of traditional large-scale ceramic tiles while giving ample consideration to the environment. This is how it looks now. The texture of real tiles convey a soft image not possible with tile-like finishes. There are many ways to use GRC. In Japan, we have opted to blend GRC with other materials to achieve a more durable product. We approach the technical underpinnings from many perspectives to ascertain the safety of the product. If you encounter difficult technical challenges, please let us to share the opportunity to take up the challenges together. Thank you so much for your kind attention.